Hey there, it's Mr. P. We're going to get started here going over how to use your triangles for your kinetic and potential energy calculations in case you missed it in class or just need a refresher while you're doing this on your own. So I'm going to start with the potential energy triangle. The potential energy triangle has 4 different parts. First, we have potential energy, which is at the top. Potential energy is measured in joules, which is a J. On the bottom, you have M, which represents mass. That's measured in kilograms, which is kg. G is gravity. Gravity on Earth is 9.8 meters per second squared. So you're always going to have gravity as this 9.8 number. You're never going to need to have to solve it or find it. It's going to be there. Finally, we have H, which represents height. And that's going to be measured in meters, not to be confused with mass. So you have your potential energy up top, mass, gravity, height. So those are your current variables. Depending on what the question asks for will determine what you're going to be solving for. So how we use the triangle is when the question asks you to do something like solve for mass or solve for the potential energy or what is the height, you're going to use this triangle. So for starters, if it asks for potential energy, you're going to cover up whatever it asks for. So I'm going to use this box to represent like your finger covering it up. When you cover it up, you are left with M, G, and H across the bottom. When things go side to side, okay, you multiply. And, oops. And when they go up and down, you divide. And when they go up and down, you divide. So what we're left with here is the information going side to side. Since going side to side, you're going to multiply. So for potential energy, you're going to do it by mass times gravity times height. So then you take the information from whatever question you have, plug in the number for mass, plug in the number for gravity, which is always 9.8, and then plug in the number for height. Multiply them all together. That's your answer. It'll be in joules. If the question asks you to find the mass, I'm going to drag my block down here, cover it up, and that leaves us with PE over GH. So if you look closely, you can see that there's PE here, and then it's over G and H here. And that leaves you that math problem. So you're going to use the math that's left over to do that. So don't be confused as to what that is. It's literally revealing the equation for you, which makes your life a lot easier. So what I'm going to do here is to solve for M. I have literally PE over G and H. So it's G times H. That's how you solve for mass. You plug in your numbers, that's what you get. Careful doing the order of operations here. I have a lot of students that type in the potential energy divided by gravity, then multiply it by the height. That's not the same thing. So you got to be very careful when you do this. I like to do the parentheses first so you get one big whole number, and then you just divide the potential energy by that number, and it leaves you your mass, which remember is in kilograms. All right, and next we're going to do the height. So for the height, I'm going to slide this over here. If you cover it up, it leaves me with the potential energy on top, the mass and gravity on the bottom. So when you're solving for height, you can use the formula PE divided by M times g. I'm going to put it in parentheses again, just to show you that that's what you do first before you do anything else. This is how you use a triangle to solve for anything that you might see. All right, next we're going to move on to kinetic energy. So for kinetic energy, the triangle works the same way. Let me get another box back. All right. So what I want you to understand is, like, when you see this box too, like, you're going to see this triangle in the system many times over this year. So if you learn it once, I know it might be a struggle right now, but once you learn it once, it really does click and you won't have to really even learn anything new the second time through. So kinetic energy is also measured in joules because it's energy. This 1/2 down here is just the number you use is part of the equation. So I like to rewrite this as 0.5 because it just kind of clarifies it for the student. They're not trying to put in a fraction in where you need to put a decimal into your calculator. M is mass again. So mass is in both equations, and mass is still measured in kilograms. Now, velocity, okay? This is what V stands for. Or it could also be speed. So both are the same thing. Now, notice that it is squared. That is vitally important. A lot of students miss that and they don't use it correctly. Okay, so don't forget to square the number that's there. And the number in the questions you see will not be squared for you, so you have to do it yourself by multiplying it by the same thing. So when you rearrange these formulas, all right, I'm going to go ahead and we're going to grab this. All right, so if the question says, what is the kinetic energy? Cover it up, and then that leaves you with the formula, KE, and you have anything across bottom, remember, you multiply. Anything goes side to side, multiply. Anything left goes up and down, you divide it. So 1/2, 0.5, times mass times the velocity squared. Don't forget that square. And again, order of operations matters. So again, I like to square velocity first, then multiply it by mass, and then multiply it by 0.5. If you do it the other way, it's going to square your answer at the end, and that's not the right answer at the end of the day. So make sure you're doing that correctly. All right, so if I move the block down and the question says, what is the mass? This is what you'll be left with. All right, so for the mass, that's equal to, actually I wanted a different color. Get this out of here. Let's go with blue last time. All right, so we get that. We get the mass is equal to the kinetic energy in the question divided by 0.5 times velocity squared. So order of operations matters again. Please be careful to do this first, then multiply that number by 0.5 to get your answer. Then divide that by kinetic energy. So this, again, order of operations matters. A lot of times I see students get the wrong answer when they set it up correctly. Finally, you have velocity squared. So if we want to find the velocity, if it says what is the velocity, what you need to do is multiply it across by 1/2 and divide it by the kinetic energy. But what the big trip up here is a lot of students will not worry about the square. They'll forget about the squared part. So let me try this again. So the speed or the velocity is equal to the kinetic energy divided by 0.5 times the mass. Now, this is V squared. If you just solve it straight up, you'll get the V squared number. Nobody wants the V squared. You just want V. V is the plain number that you're looking for. So in order to get rid of a square root or square, you need to take the square root. So whatever you get here, you need to take the square root of that whole thing. That will get you the number that I'm looking for. That's going to get you the right answer. So a lot of times students forget to do that. So what I like to do with this one is you do all this math first. It's inside here. Do that first. Then take that number you get and take the square root of that. It's a lot easier than trying to punch it in your calculator all at the same time. That's the right answer. So please be very careful when we're asked to calculate the speed or the velocity, because students get tripped up a lot there as well. So that takes us to the end of the tutorial. Make sure you are doing your best to try. I want to see you try before you come to me for help, and then I can fix that because you're smarter than you think, and you probably are doing most of it right, but maybe need help on a small portion. Please reach out to me if you need any further